So today I'm going to talk to you about things that are non-academic, things that we're doing here at Robust Intelligence that relate to how we eliminate AI risk, one model failure at a time. So I guess we all know, and in this audience, that AI is eating the world, right? And we can, we can basically think about this if we try to plot like the growth in how much organizations are spending on AI products, right, over time, and we're seeing that there's just massive growth and adoption. But probably everybody in this audience knows this from a different perspective and knows that AI is eating the world just simply from, just talking to all these organizations and seeing that basically every company that you can think of or can think of right now is in some way deploying AI models into its systems, right? But the problem is that while AI is eating the world and the technology is really amazing, we know that AI fails, and it fails all the time, right? So AI models fail in some cases because of corner case inputs. In some cases, AI models fail because basically they make biased predictions when we feed them one training data and then have them apply them on a different data set from a different demographic. We know that AI models can produce unexpected output. So here we have a picture of, I think it was called the Tay-bot, for those of you who remember, the Microsoft release in 2016 that they put out there, right? And it basically survived less than 24 hours because it was feeding off of Twitter, right? And people figured that out, and then they gave it input from Twitter and then made it into the racist bot, right? So we have these unexpected, model behaviors. And then there's, we all know about shifts in data distribution, that have AI models fail, right? AI models fail because of adversarial input. This is as old as, email or, fraud detection. And now we're seeing more and more modern applications of adversarial input. And of course, it fails because of broken data pipelines, right? So really, when organizations are adopting AI, they're adopting a lot of risk, right? And when we're thinking about AI risk, we think about the new set of operational challenges that organizations are facing, right? That is not, included in traditional software, systems, right? And the causes for these risks are distributional drift or unexpected model input, everything that we talked about earlier, right? So if we think about for a second, as in terms of as an ML ops community, right? When we think about where is the pain of AI right now, right? So a good way to think about this is to think about kind of how it's trending and how it's shifting, right? So if we think about if we kind of close our eyes for a second and we think about where were we as a community in 2015, right? And what was the biggest pain of an organization that was trying to adopt AI, right? So in 2015, right, I want to remind you that this is, predates TensorFlow, predates PyTorch, predates scikit-learn, right? And a lot of really great open source libraries and open source tools, right? And so this is a time where, we had not a lot of people who were skilled at, AI. And then the biggest pain was actually in AI development, right? If you just kind of want to, just even play around with data, just figure out whether, linear regression is going to do anything for you, right? That was not a trivial thing to do. You'd have to hire, probably a, PhD grad from a top university who would code up in C++, an algorithm, right, that would allow you to do that, right? So AI development on its own was a big, big issue in 2015, right? But fortunately, with all the open source software, that has come out and all, a lot of really great work that's been done by companies like DataRobot and, C3 and H2O, right? AI development, right, is really not, today AI development is not a big problem for, many organizations, right? If you talk to organizations today, most of them are going to be concerned with AI deployment and AI risk, right? With AI deployment, what I mean is, I have an AI model. I know that it can bring value to my organization, right? But now what I'm concerned with is I'm concerned with actually putting it into production, right? And now once I have that figured out, right, immediately my next concern becomes AI risk, right? So if we try to imagine, where the world is going to be in 2025, right, just a few years from now, then basically AI deployment is going to be in the same way that AI development has become a solved problem. AI deployment is going to become a solved problem, right? But risk is something that we as a community are going to, continue on dealing with, right? Because model architectures change, right? The threat vectors change, corner case inputs, that all these things, they don't end. So as a community, we're going to be finding ourselves spending a lot of time here. So really, if we think about, as a, like this being an MLOps conference, when we ask ourselves, what should be the focus of, the MLOps community? Or, we sort of ask ourselves, when we meet again 3 years from now, right, what are most of us going to be talking about? Most of us are going to be talking about how to eliminate AI risk. And a different way of saying this is to say that really we're going to be dealing with how do we introduce machine learning integrity. Okay. Okay. So today, what I want to talk about is I want to talk about a test-driven approach to machine learning integrity, and I want to use this slide, just to give you like the 3 important bullet points that I want you to remember if you had to leave this talk right now. Okay, if you had to leave this talk, you have to zone out. You really have to check Slack, right? Maybe maybe you have a model in production that just failed, right? So before you go off, right? These are the 3 bullet points that I want you to take away, go home with. Okay. So I want you to remember that model failures due to bias, bad input, drift, adversaries, they're all just symptoms of AI risk, right? And we shouldn't look at them as disjoint problems, right? They're symptoms of AI risk. And every one of these symptoms of AI risk can be mitigated through a well-designed test, okay? And the last bullet point, and this is, that I'll talk about is, I want us to think about testing as a powerful framework or a concept that allows us to build a system that can test, prevent, and basically monitor symptoms of AI risk and enable ML integrity. Okay? So all these sort of issues that we have with models when they're going to production, we should think about them as risk, right? And the way that we can mitigate risk is through well-designed tests, right, that can build a system for, basically preventing models from failing and then monitoring, like, these model outputs. Okay. All right, so for the rest of the talk, what I'll do is I'll talk a little bit about the ML lifecycle and the challenges. Probably most people in the audience, know like already too much about that, but we'll talk about that just to sort of have unified language. And then we'll talk a little bit about, what do we mean when we say ML integrity? And then we'll talk about a test-driven approach to ML integrity, and we'll contrast that with a business analytics or business intelligence approach, that we currently see a lot of, right, for achieving, ML integrity. And then we'll go with a quick case study. Okay. All right. Okay, so when we look at the ML lifecycle, okay, basically, right, we can think of the ML lifecycle as starting from data engineering, going into a process of model building, and then going into a process of model ops. And of course, it's more complicated than that. When we have data engineering, there are processes of data cleaning, data exploration, right, and feature engineering that all go into this process of preparing data. And all these are not without their challenges, right? So when we're facing this process, when we're in this period of the data engineering part of it, what we're facing is, like, from a technical perspective, we're facing with broken upstream pipelines, we're facing with outliers that live in the data, right? We're facing data leakage, we have to like find smart ways of doing feature selection, and we have to make sure that we avoid oversampling, right? These are some of the technical challenges, right? When we look in the model building part, right, from training to evaluation, tuning the model and retraining the model, right? Then we stumble upon all these other, challenges, right? We have to figure out like performance on edge cases. We're struggling with kind of underperforming subsets in the data, which also, in the same way it also can introduce bias for protected attributes, right? We have vulnerability to data corruptions. You can have the model that's, being vulnerable to evasion and adversarial attacks, right? And then later on, we basically need to kind of like understand how do we kind of create, these smart heuristics that tell us like how to select, the best model and what the decision process should look like. And the final piece when we're thinking about ML ops, right, or the model ops, sorry, then really, then we have like, again, a whole new set of challenges, right? We have to make sure the data is, free of corruptions. We have to make sure that we have consistent schema. We have to, kind of figure out what is it that we do when we see degradation of model performance, like over time, right? And then we have to sort of see how do we estimate performance in the absence of labels. I have to deal with debuggability and automating retraining pipelines. So these are all challenges that we, we take upon ourselves, right, when we're putting models into production. So from all these are kind of like technical risk, aspects of this and technical challenges, but all these technical challenges, right, they translate into risk, right? So, from everything that we've seen from data engineering, model building, model ops, these are all challenges that have to basically translate into risk when it regards to model performance, fairness, security, and transparency, right, of the ML system. So what is machine learning integrity? Well, machine learning integrity is basically, we need to think about this as the set of practices, right, that we can use to eliminate risk throughout the entire ML pipeline or ML lifecycle. Okay? So how do we achieve machine learning integrity? What I'm going to do is I'm just going to talk about like our approach to machine learning integrity, which is what we call a test-driven approach. So before we talk about what is a testing-driven approach, it's good to talk about what is it not, right? And what it's not is not an approach that we've seen, that we kind of like have seen in other spaces or other areas, which is the kind of the business intelligence or business analytics approach, right, for tracking customized metrics. Okay, so in other areas, not in machine learning, right, business analysts. They really rely on business intelligence, right? And basically this approach says, we can track customized business metrics and KPIs through, the use of dashboards, right? And that works, really well for analysts. So if we kind of like adopt this approach, right, to, kind of like securing or, the machine learning pipeline from risk, right, then basically what we would do is we would feed in the model output, right, and feed that into kind of take the model output and kind of set some some thresholds for KPIs, right, and then what we would do is we would build some dashboards around this, right, and then kind of have a data scientist or an analyst, right, that can go over and see when kind of like what's happening to the metrics that we've defined, right, so we can see what happens to kind of like model performance. We can see, what happens to like prediction score, what happens to, various kind of metrics that we can decide upon, a priori. The advantage of a BI approach is really is that it's kind of like very easy to implement and set up, right? And that's why if you're a data scientist, right, and you kind of you're developing on your notebook, and now you have a model that's that's running. It's very quick and easy to set up this kind of like business intelligence approach. And as that step, that's probably what you should do. Kind of like the first thing that you should do probably after you've graduated from a Jupyter notebook is to kind of now track what kind of like basic performance metrics of your model and see what it's doing, right? And the reason it's easy to do is because, well, first of all, it's contextless, and really requires like no understanding of machine learning at all, right? So even if, and I mean that in the best possible way, right? You don't need to be a machine learning engineer, you don't need to be a data scientist in order to be able to, to do this and use these tools, right? You can be an analyst and you can also build these tools without any knowledge of machine learning, right? So basically, you can basically treat the output of the machine learning model as, as a business metric, right? And just use that, and that's great. And the second appealing option here is that there are a lot of really great open source visualization tools, right, that allow you to kind of create dashboards very quickly and customize dashboards, and that's a great that's a great advantage of this. And then that way really everybody can get started pretty quickly. If we want to use that as a tool for what we call machine learning integrity, then it's not ideal, right? When we're thinking about, when would you want to use, when would you want to, when do you care about machine learning integrity? It's not at the very the research step, right, or the stage. You care about machine learning integrity when you're thinking about this now from an organizational perspective, right? And now you really want to make sure that your organization is not exposed to all these risks when the model is going into production, right? So from that perspective, right, the BI approach, it basically tracks the performance of the model, but it doesn't really track the model failures, right? And that's a different thing. So you can track when the kind of prediction scores go down, but it doesn't really tell you anything whether the model is failing or not, right? Importantly, and probably this is the most important point, basically the BI approach doesn't, it helps you with tracking, but it doesn't do anything for prevention, right? So it's kind of like, the difference between, knowing that your house was on fire last week, right, versus something that can actually prevent that fire from happening before it happens or prevent it from happening in real time, right? So when we're using that approach, right, we just have to acknowledge, right, that we're not doing anything to actually prevent models from failing, right, but we're just sort of, tracking that they failed. Another part of it is that it leaves risk to the analyst, right? Because the analysts come up with their own KPIs, right, and their own metrics, right? And now basically we've offloaded risk to whoever is setting up these dashboards and metrics. Another part that again relates to this is that it's very difficult to standardize quality across an organization, right? And finally, when we're thinking about, if you meet a company today that has, a handful of models, next year they'll probably have tens of models, and then a year later, they'll probably have hundreds of models in production, right? And when you're thinking about, having to customize dashboards and kind of metrics for every one of these models, that just doesn't scale, right? So that's why it's a very good approach for, getting started, but it's not really a good approach for an organization that is thinking about deploying, a serious number of models in production. Okay, so if not the BI approach, then, what should we do? Well, we should probably look at kind of what other, what our friends in software engineering and security do, and what they really do is they take a testing-driven approach to avoiding risk. Right? So what is a testing-driven approach? Well, it's pretty much in its name. The testing-driven approach basically implies that what we want to do is we want to create automated tests, right, of these different AI risk symptoms, right, that basically just pass or fail, right, with different measures of severity, right, according to the impact that they have on the model. Okay? So basically, what we're saying is that rather than, setting up customized tests, write software where in that software you're basically defining, a test, and then you can test for different, different attributes in the data. You can test for different attributes of, the model. You can just create a series of tests. And then every test needs to pass or fail with different levels of severity, and passing or failing can depend on, the impact that that a certain test has on the model performance. Okay, so basically, it's not that you're only connecting the output of the model, right, to testing. Basically, the idea is that you're going to be testing throughout the entire pipeline of the model lifecycle. Okay, so if you're taking the BI approach, it's contextless. You're building and maintaining customized dashboards. It requires human interpretation, and it's hard to standardize across an organization and across teams. And with the testing-driven approach, you'll be setting up tests against expectations. You'll create you'll have binary decisions. You'll create an organization-level kind of benchmarks, right? They're using the tests, and it'll be kind of extendable from offline to online evaluation. So let me give you just a kind of a quick example of what a testing-driven approach is to, a simple kind of like unseen categorical aspect, and then I guess we can open up for questions. Okay. So the running example that I want to use as a case study is just imagining, like a case of, the simplest case that we can imagine. We have some XGBoost model, right? And then we basically we want to look at the problem of unseen categoricals, right? So basically, it's a tabular model, and now we want to deal with the fact that there are unseen categoricals that that can come into the model and create a model error. So in the first part, right, we integrate with the data alone. And from the data alone, we're just going to generate tests. And what those tests are going to do is they're just going to basically look at whether or not we have unseen categoricals in our data. And if we do have unseen categoricals in our data, these tests can actually, we can basically measure how they impact the model performance through statistical tests. Okay? And that's actually something that we do in the company. Okay? The second part, when it comes to model building, right, we can look at whether the model in itself is susceptible or vulnerable to unseen categoricals. So here what we would do is we would use the model, and then we would take the data, manipulate it, create unseen categoricals, right, that are hopefully realistic, right? And then we'll feed that into the data to see the robustness of the model to these unseen categoricals, right? And based off of that, we can decide whether we want to retrain the model or protect it in any other way, right, for unseen categoricals. The third part, when we're actually putting the model in production, right, we can then use these tests to create an AI firewall. So we can use these tests now that we've understood that, in this case, unseen categorical on a certain feature can have an impact on the model performance, right? We can compile those into, you can think about these as maybe like a set of rules, right? And now these set of rules can be wrapped around an existing model so that every time that a data point comes in, right, we can actually test whether they're unseen categoricals, right? And we can make that decision of what we want to do with these unseen categoricals. And here we can basically flag, okay, we have a data point, it has an unseen categorical, right? We flag it and we say, what is the unseen categorical that that we're observing, right? And then on the final piece, right, after the model is, when we're looking at the prediction logs of the model, we can just continuously test, the model and the data through what we call continuous testing, and just continuously run these tests. And as we're continuously running these tests, we can see that all of a sudden, in this case, there's a surge, in this case, right? And it's a surge in kind of like one of the tests continues to fail, right? And we see that this test is the test of unseen categoricals, right? That is actually happening to the model, in production, right? So by doing that, we're not only monitoring the model performance, right? But basically when we're running, like if you think about like running hundreds of tests, which is what we do in the company, right, on models in production, right? Then basically you're seeing you're seeing kind of like the reasons for why the model performance is acting up, and you're doing kind of immediate root cause analysis through these tests. Okay, so what are the takeaways? So I think that one of the big, I think the main takeaways I put down are basically kind of like these 3 bullet points. So one of the biggest pains I think of production ML is AI risk. Yeah, and we talked about why. Model failures due to like bias, bad input, drift, adversary, they're all symptoms of this AI risk. And the final piece is, and I hope I managed to somewhat convince you, that the way to deal with AI risk is really a testing-driven approach. And that testing-driven approach can be used for models offline to test the model, right? We can use it to, when the models are in production, we can use that to prevent models from failing. And then we can use that to monitor all these symptoms of AI risk and achieve this ML integrity. So with that, I want to thank everyone. And you're welcome to email me at my email. This is Yaron at Robust Intelligence.
Really interesting talk. I think all of us, or many of us, are familiar with test-driven development in terms of software. So test-driven development in terms of machine learning is very fascinating, and I feel like I'm convinced by your talk. I'm curious if you have done this previously, or you have ideas about how to test for like ethical considerations in models, like testing for the bias in terms of like the output of a model, something like that.
Yeah, absolutely. That's a great question. So, the question is like, can we apply testing-driven approach to test for ethical issues with AI models? And the answer is absolutely, right? Because whenever we're thinking about any sort of like bias issues that we have with models or data, right? They can all be basically translated into a well-formulated test, right? And when we can when we can map kind of like our considerations for bias or fairness, right, into a test, then we can apply that test, and then we can see whether the model passes the test or fails the test, and we can treat that accordingly.
Hi. Thanks for this. This has been really great. Just had a question, like maybe an example of adversary failure, and then how do you mitigate against that?
An example of adversarial failures? Yeah, so we should have someone else in the company that we have here talk about this. So we have someone in the company who is the head of Microsoft AI red teaming, and he can talk a lot about like the actual like attacks that they've seen at Microsoft and other places. But I like us all to think about, when we're thinking about like adversarial input, let's think about spam, right? That's kind of like one of the earliest examples that we all remember, right? Like email spam is a great example of adversarial input. And then there's everything that has to do with with bots that are crawling websites. When we're thinking about adversaries that are trying to do anything in their power to avoid fraud detection, from payment companies, those are all just kind of like benign examples, but these are all like adversaries that are actively trying to fool machine learning models for tabular data. We see there are actually a lot of other examples, for adversarial input. There's, you see like kind of, if you remember, it's a huge space, but like, we saw, for example, like when OpenAI released their, I think it was like their GP2 model, right? Somebody just kind of, queried the model and then basically stole the model, right? By doing that, right? So, there's no shortage, unfortunately, of adversarial behavior when it comes to machine learning, like from 20 years ago, like all through today.
I'm just wondering if you have any pointers on how do you time and synchronize all these tests so that you can avoid them from being like lagging indicators versus them being leading indicators?
Sorry, so the question is how do we synchronize all the tests?
Yeah, how do you time and like any pointers on how you actually time and synchronize and where and when and on the timeline of the cycle?
Yeah. So I mean, we have our own approach, right? And our own approach is basically we have a suite of tests that apply to to models before they go into production. We make that distinction for models before they go into production and for models during production and after production. So basically, we run a series of tests on data, the model itself, and other aspects, right? We test for feature engineering. We test like kind of basically every aspect of during the ML lifecycle, right? We can is testable, right? And you can create like an appropriately designed test for that, right? And then while the model is in production, you can basically take the results of the tests, you can compile them into what we kind of like this AI firewall, right? At minimum, you can think about this as a set of rules, right? That's automatically generated from the tests, right? And that can be used to like actively block or flag bad data points, right? And then at the last piece, you can kind of like continuously test your model when it's in production, right? And run the same tests, right, for that.
Thank you. That was a great talk. I'd like to ask you a quick question. Not sure it's a quick or not. Could you shed light on scalability of this approach? I know you spoke about that this approach is more scalable than, say, a BI approach. Could you shed a little bit more light on saying that why is this you think this approach is more? It's unclear in my head.
Yeah, absolutely. So I think it's, you know, some of these tests are computationally intensive, right? Not all of them, but especially you can think of like very tests for like adversarial input. Some of those can be very computational intensive. Some tests are not. So then that's a different issue. But if you think about this like from an organizational perspective, if you think about if you have like now 100 models that are running in production, right? And you have quite a few customers that that do have this problem, right? And now when you have hundreds or thousands of models in production, if you now think about having to set now think about the BI approach, and think about having to set a threshold, right? On when do you want to be alerted that the model is failing, right? And now you have to like set a threshold for what is the performance degradation, right? So for every one of these models, right? It just it's very difficult to scale when you have like hundreds or thousands of models that are running into production. Not to mention when you have hundreds or thousands of models that are feeding into each other, right? And of course, when you have the fact that like these models are automatically retrained, right? Or that you're kind of like retraining them in the organization. So just from that perspective alone, right? If you think about like having to like manually set every one of these thresholds, right? That's very, very difficult to scale, right? Versus something that runs as a CI/CD process and just automatically does all this.
I'm wondering, in certain organizations I've been involved in, there hasn't been an ability to quantify AI risk, and that makes it difficult to get buy-in from stakeholders that it's important to implement something like robust intelligence, like implementing something to mitigate AI risks. I'm just wondering, have you gone through the exercise of quantifying AI risk to make a better business case?
Yeah, I mean, so whenever you're talking to an organization, right? Like the first question, the first question is like they probably want to understand is like why it matters to them, right? If it doesn't, some organizations, we've come across like some companies, for example, maybe that. We've seen some companies, for example, that do like online advertising, and model failures are not that important to them, right? It's not critical, right? But then there are then there are organizations that very much care about AI model failures, right? Whether because of the fact that they're losing a lot of money whenever there's whenever there's an error, right? Or they're building they're a medical device company that's that's building software that that automatically makes recommendations for patients, right? So there it's like it's a huge risk, right? So so in every one of these cases, they like in these different areas, they know how to quantify it. Sometimes it's kind of pure financial loss. Sometimes it's reputational damage. Sometimes it's like literally kind of like people's lives at risk, right? So they quantify it in different ways.
Yeah, that definitely makes sense. Thanks very much. Well, let's thank Yaron. Thank you very much.